Hello, I'm Kaeini. We are going to solve another question from A-level past year paper. This is again the code of the paper is 9709. Sorry, this is paper 1, variant 2, February-March 2019. This is just for the last February-March examination. It is from the calculus part of the question paper. There is a curve. We are going to rotate the curve to get a 3D shape. We are going to find the volume of that. Therefore, this is the shaded area which we are going to rotate it about the x-axis and then find the volume of this 3D shape has been generated. Okay, now let us see what the question says. The diagram shows part of the curve. Sorry, I didn't write the curve. Curve is y equal to second root of x cubed plus x squared. Therefore, this is the curve. Now, the shaded region is bounded by the curve, x-axis, and the line x equal to 3. Now, find, showing all necessary working, the volume obtained when the shaded region is rotated through 360 about the x-axis. Therefore, this shaded region has been rotated and we are getting a 3D shape. We are going to find the volume of that. Now, you know that the volume is actually, the formula is this, V is equal to pi integration from A to B y squared dx. For pi is a constant number, you can have to write it. Integration from 0 to 3, therefore integration from 0 to 3, y squared, y is this, a square of this, therefore a square root of x cubed plus x squared, then to power of 2 dx. We know that a square root of something to power of 2, that means only this value here. Therefore, these two cancel each other. Therefore, this is pi. Therefore, 0 to 3. So we are going to get x to power of 3 plus x squared dx. Now, this is very simple to calculate. We know that if we have integration of x to power of n dx is equal to x to power of n plus 1 divided by n plus 1. Therefore, here will be x to power of 4, 3 plus 1 divided by 4 plus x to power of 3, that is 2 plus 1 divided by 2 plus 1, which is 3. The values started from 0 to 3. Therefore, we have to substitute here minus this. Therefore, this is the answer is 3 to power of 4 divided by 4 minus plus 3 to power of 3 divided by 3 minus, putting 0 here will be 0, here will be 0, therefore minus 0, which no need to calculate that. Now, this is 3 to the power of 4. You can put this in the calculator and get the final answer, but anyhow, 3 to the power of 4 is 81 divided by 4, and this will be only 9. Therefore, the answer will be 36 plus 81, which is 7. This is also 11. Therefore, this is 117 divided by 4. Oh, sorry, I have forgotten the value of pi here. Therefore, there is a pi here, there is a pi here, there is a pi here, and there is a pi here. Put this in the calculator. You are going to get 91.9. Therefore, this is the value of the volume generated when you are rotating this about x-axis. Okay, this is the first part we have done. Therefore, this 91.9 unit cube. Now, second part of this question, sorry again. Second part of this question says that at the point P, this is the point P is here on the curve with the x coordinate 3, which we know that already. Therefore, this is the x coordinate. Find the y coordinate of the point where the normal to the curve at P crosses the y-axis. Therefore, there will be a normal here. Therefore, there will be a normal here. This is a normal, which is normal to the curve. This will intersect y-axis somewhere, you know, it goes out of the whiteboard. So you are getting some point there. We want to find the value of that. Okay, first of all, we have to find the equation of normal at the point P. Let me erase this and let's see what we want to do. Actually, we don't need this also, this part. Okay. Okay. Now, we have y equal to square root of x cubed plus x squared. This is exactly the same as that. I'm going to write this in the form of exponential format. Therefore, this is actually x squared to power of half. Okay. Now, to find the equation of normal, I need x, y, and also I need the gradient of the line. Okay, first of all, to get the value of y, I know the value of x. I can substitute here to get the value of y. Therefore, I know x is equal to 3. Therefore, y will be equal to the square root of, this is 3 to the power of 3 plus 3 to the power of 2, which is 27 plus 9, which is square root of 36, which is 6. Therefore, the point P, x is how much? X is 3, y is 6. Therefore, we have the point P. Now, we need to find the gradient of the normal to the curve. If we want to find the gradient of normal, first I need to find the gradient of the tangent to the curve, because normal is perpendicular to the tangent. Therefore, let us find the gradient of the tangent. For that, I need to find dy by dx. dy by dx, okay, let me first explain something here. If we have y to power of u to power of n, dy by dx of this function here, write it nicely. If y is equal to u to power of n, you know that dy by dx of this function is n u to power of n minus 1 times du by dx. That means you are bringing the power down. Oh, sorry. That means n u to power of n minus 1 times du by dx. That means, as usual, you are bringing n down here, reducing 1 from the power, then forget about the power, differentiate the base. Now, look at our function. Now, our function is x cubed plus x squared to power of half. So, dy by dx is equal to, this half comes down here, therefore half you bring down, and then reduce 1 from the power, will be half minus 1. Then after that, forget about the power, differentiate the base. Differentiate the base, therefore, which is 3x squared plus 2x. Okay, therefore, this is the value of dy by dx. Now, this is actually negative half. This means actually 1 over 2 square root of negative half, therefore it will be in the denominator, x to the power of 3 plus x squared times 3x squared plus 2x. Now, we know that x is equal to 3, substitute here to get the value of this. At x equal to 3, dy by dx is equal to 1 divided by 2 times, this is 3 to the power of 3, which is 27, plus 3 to the power of 2 is 9, times 3 times 9, plus 2 times 3. Now, this you can calculate is 12, and this you can calculate is 27 plus 6, 27 plus 6, which is 33. Now we can simplify by 3, you're going to get 11 over 4. Therefore, the gradient of the tangent is 11 over 4. Now, this is the gradient of the tangent to the curve. We want the gradient of the normal to the curve. We know that normal is just, if we call it m1 and m2, we know that m1 times m2 is negative 1. If this gradient of the tangent, this will be gradient of normal. Okay, then if you substitute here, this is 11 over 4 times m2 should be negative 1. That means m2 is equal to minus 4 divided by 11. Therefore, we got the gradient of the normal. Therefore, this is the gradient of normal. This is sufficient to substitute in the formula. What is the formula? Formula of any line. When you have the gradient, you have the point, you can write the equation of the line, which is y minus y1 equal to m times x minus x1. Y minus y1 is how much? Is 6. M is minus 4 over 11. X is your variable, minus x1 is 3. Therefore, this is the equation of the normal to the curve. But what we want is the point of intersection of this line with y-axis. Therefore, I need to put x equal to 0 here. So if I put x equal to 0, sorry, I'm going to write it here. Let us see if I will erase that part, which we don't need. Now, we have this equation of normal that we need to put x equal to 0 to get the value of y-intercept. Therefore, x is equal to 0, so y minus 6 is equal to negative 4 over 11 times 0 minus 3. Therefore, this y is equal to 6 plus 12 over 11, which is 66 plus 12 over 11, which is equal to 78 over 11. Therefore, this is the final answer for this question. If you want me to solve any question for you, put them in the comment section below, and I can go through that, and then I will solve it for you and put it in our channel. Thank you for watching.